So this is a quick YouTube video on the ANET A8 3D printer that I bought a couple of weeks ago, and just to kind of put in my 2 cents on my experience with the unit. So basically I have done several 3D prints with this printer. It took me a day or so to put it together. I didn't work on it full time. I worked on it maybe a couple of hours each night, and it was relatively simple to put together. The instructions um, could have used a little bit more polish. I could figure out what they were trying to tell me to do. I was using the PDF installation instructions, but they could have been a little bit better. A real quick suggestion is when you're putting this thing together, what you can kind of see right here, I'm moving the cursor around in this area, is it has these little machine screws that get put together, go through holes, and you put these nuts into slots, and then you screw things together. And it was kind of difficult for me to do. I don't necessarily have the biggest hands in the world, but it was, these screws and these nuts are small. So my suggestion is that you go get some simple, not masking tape, but just Scotch brand tape. And what you can do is you can tape the on one side of these slots on all these pieces that you're getting ready to put together, and then you can put the nuts down in the slot and they will stick to the tape. By doing this, then you can, it's a little bit more, it's a little easier to put this thing together, and you don't drop the nuts all over the place. The other thing I would strongly suggest is to go to Walmart and get you a 8x8 picture frame that has glass in it. It's about $5 to $10. There's a section in Walmart, just like if you were going to frame a picture between a piece of wood and some glass. And you can get these picture frames with 8x8 glass panes in them, and they work perfect in order to clamp onto the heated bed. I tried to use the blue tape, and I had mixed results. Didn't really have that good of results. I started running into lifting and warping, and as soon as I went out and I put a piece of 8x8 glass, is probably about 1/8 of an inch, 1/16 of an inch thick, and I clamped it down with little clips that you can get from the office supply area in Walmart. It worked great, and I would strongly suggest doing that. Also getting maybe some rubbing alcohol. I also got some Elmer's glue and mixed it with a little bit of water, and you can slowly wipe that glass surface as the unit is heating up, and it will put a nice, very thin coat of glue on your heating plate surface, and you will have really good prints. Basically, I did that, and other than maybe tightening the y-axis belt a little bit. You see these little screws right here. You can adjust these and tighten the belt up. That's all I really did. The unit worked so far flawlessly. I would also suggest that there you'll see people talking about dismantling this fan right up here, and it has a heat sink, and in order to put the filament through there, this fan is they had it bolted down. Well, what I did is I didn't use the heat sink. I just used a piece of Velcro to hold kind of the fan on there. Probably the best thing to do, but it seems to work for me. Also, make sure you plug in your little cooling vent right here, because that will affect your prints significantly. So the only other thing that I kind of messed up when I was putting the thing together is I would run all your wires, and get them all nice and put together before you put this little spiral sheathing on these wires. Because if you get in a hurry like I did, you'll end up leaving some wires out. And I forgot to put this fan on and put the power wires to the fan. Also, you might want to take your time when you're putting together this motor and these rollers. There's some bolts on the back that you have to screw back in when you're putting the belt on. And I ended up having to take this motor back out in order to do that. So you might want to get all that, the belt, the X belt in place and tightened up before you put this motor back in. So I just went out real crazy like and said, I've got to get one of these 3D printers, and I am really satisfied with it. There's some newer or different technology printers out there. You'll hear a lot about this Bowden extractor and these other E3D heat ends. I'm probably going to go in that direction to get, basically they're taking this motor off of here and moving it somewhere over here, and that makes this XY head or whatever this thing's called, platform, move back and forth much faster, and there's not as much mass accelerating and decelerating in here. So anyway, there's some MOSFET upgrades. I haven't bothered with that. And there's people that solder the wires to the back of the plate. I haven't gone there either. So the unit seems to work for me. I've already printed out some things that have to hold some servos. The next thing I would strongly suggest is download SketchUp, which is a little CAD program, and get that installed and start doing your own 3D modeling. I am not a 3D modeler, but I got up to speed real quick, and I basically printed out a spool for holder for this mechanism for the shaft right here. This has a lot of drag on it because it's just sitting on a rod. So I printed out a 3D spool that rides on this axle, and then there's much less drag on this. So that took a while to design, but you're going to be wanting to get involved with 3D, the 3D software, and kind of learning how to do your own 3D designs, There's a lot of things you get online. Like I was interested in these servo arms. They have different dimensions, and even though you load these things into Kira, which is the software you use to write the G code that this thing ANET runs off of, it you can't tell what the scale is, and you don't really know what's going on. So I would strongly suggest downloading SketchUp. SketchUp also needs a STL plugin that you can install, so you can go directly from your 3D drawings to STLs. STL files go into Kira, then Kira makes them into G codes, which is what this thing runs. There's some Skynet firmware that you can supposedly upload to this thing, and then you can run it directly off your PC or your laptop, whatever. That's probably what I'm going to do. So anyway, this thing works really well for making relatively simple items that you can add to your ANET. If you can download them and design them. So I for the whole learning experience, it was worth the couple $100 that I spent. I also got an extra spool with the unit when I bought it on Amazon. Can't remember who I got it from, but Amazon, once you buy one of these things, they suggest to get a spool of PLA, and I got some black, and it worked really well. I'm really happy with it. But now that I would strongly suggest going online on YouTube and looking at get involved in the different designs of these units. There's already another unit that's around the same price, the Tarantula, Tivo Tarantula, that looked really interesting. And it already has what they call this Bowden extractor and the E3D, I believe, heat head, extruder head. I'm still learning all this stuff. And it's a little bit different design. You have to do some mods to it, but these units are getting out there with better designs, as we speak. Anyway, this YouTube was done on 4/25, 2017. I'm sure things will change. Anyway, if you have any questions or remarks, let me know. I'm in the process of trying to do some robotics, and I need some arms and some servo thingy-mabobs, and for a couple $100, getting this thing up and running, it has been a great learning experience. And if you're have a technical background, you definitely need one of these things. Anyway, good luck to you.